So this is the second video regarding real numbers. In the first video we have studied some questions. Now we are going to prove root 2, root 3, etc. as rational number or irrational number. What is rational number? The rational numbers are which we can express in the term of p by q, where p and q are co-prime integers and q is not equal to 0. Whereas rational numbers are in the form of p by q, where p this is can be terminating or non-terminating, and that is repeating also. Okay, so irrational number are non-terminating, non-repeating. Example of irrational number are root 2, root 3, root 5, root 13, pi, etc. are called irrational numbers. Whereas you can say root 16 is not an irrational number because root 16 will give you 4. Similarly, root 36 is also not a 36 because it becomes 6. So these become rational number. Similarly, 0 also rational number. Okay, minus 8 also is a rational number. Now we have to prove root 2, root 3 or root 5 is rational number. We'll take one example of root 5. So your first question is prove that
root 5 is an irrational number.
Irrational. Let us start with that. Let us assume first we have to prove that root 5 is an irrational number. So write down the question. Root 5 is an irrational number. Question is root 5 is a irrational number. Answer. Let us assume that root 5 is a rational number. In that case, it can be expressed in the form of p by q, where both p and q are co-prime integers and q is not equal to 0. What is co-prime integers? If there is two numbers, there is no common, we call that is voltage, their H shape is 1. That is called co-prime integers, like 8 and 9. Whereas 6 and 9 are not co-prime because there is a common 3, where q is not equal to 0. You have written out or q is not. P and q are co-prime integers. Now root 5 is equals to p by q. Squaring both sides, you can do like this. Squaring both sides. 5 is equal to p square by q square. P square by q square, or by cross multiply, p square equal to 5q square. And right here 5q square p square into 5q square. Okay, p square into 5q square. Therefore, because you multiplied by 5, therefore p square is a multiple of 5. Is a multiple of 5. Is a multiple of 5. So that one you can keep, first line you can keep as a question. Rest of it. Okay. P square is a multiple of 5. So P is also a multiple of 5 as per theorem. So therefore P square is a multiple of 5. So P is also a multiple of 5 as per theorem. We have got theorem 1.2 that says that if p square is a multiple of 5, then p also multiple of 5. Okay, as per theorem, substitute value of p is a multiple of 5. Let यहाँ पे write down one more value. Let p equals to that multiple to 5. Let p equals to 5n. Let p equals to 5n. Value of p in equation number 1. This one. Okay. So equation this will give you 5q square equal to equals to 25 5p का whole square 25 n square. 5 and 25 get cancelled. So q square equal to 5 n square. That means q square is a multiple of 5. So q is also a multiple of 5 as per theorem. Thus we find that both p and q are multiples of 5. This contradicts our assumption p and q are co-prime integers. This contradicts our assumption that p and q are co-prime integers. So our assumption is wrong and root 5 is an irrational number. Understood?
Yes.
Now we are going to second question. You can erase it. And now read the second question.
Prove that 2 minus 3 root 3 is an irrational.
Write down the question. Here also answer. Here also let us assume 2 minus this is 2 minus 3 root 3. Let us assume 2 minus 3 root 3 is a rational number. In that case, this can be expressed in the form of p by q, where p and q are co-prime integers. and q is not equal to 0. For p by q, where p and q are co-prime integers and q is not equal to 0. Not equal to 0. So we can say 2 plus 2 minus 3 root 3 is equal to p by q. Now you transfer this 2 to this side, this will give you minus 3 root 3 equals to p by q minus 2. Now you take q as LCM, you can write this side because equal to q, you can take LCM, that gives us p minus 2q upon q. Okay, this therefore root 3 is equals to p minus 2q upon minus 3p. Since you can write here, since p and q are integers and q is not equal to 0, therefore p minus 2q by 3q. Therefore, you can write here, you can rearrange and write that because therefore p minus 2q upon 3p, 3q, p minus 2q upon 3, it was minus 3q, no? Somewhere minus 3q is a rational, therefore is a rational number. Whereas we know root 3 is an irrational number. Since since rational number cannot be equal to irrational number, irrational number, so our assumption is wrong. And 2 minus 3 root 3 is an irrational number. Is an irrational number. Okay, understood? So we are doing one more question, last and final question. That is, almost everywhere you have to do same thing, only number change, but pattern will be same. I think I told you two types. Now last one is you have to prove that 1 by root 3
is an irrational number.
irrational number. Note down the question. You have to prove 1 by root 3 is an irrational number. Same way, let us assume 1 by root 3 is a rational number, then it can be expressed in the form of p by q. So it can be expressed in the form of is a rational number You just is a rational number, so it can be expressed in the form of p by q, where uh, p and q are co-prime integers. P by q. Okay. One by root 3 equals to p by q, squaring both the sides. You can make here also, squaring both the sides. 1 by 3 is equals to p square by q square. P square by q square, or 3p square, cross multiply q square into 3p square, q square into 3p square. Therefore q square is a multiple of 3. So as per theorem, q is also multiple of 3. You can use that one also, because getting some dark. Therefore q is also a multiple of 3. Multiple of 3 as per theorem. Let us assume q is equal to 3n. Here q square is put number 1 here. So substitute the value of q in equation number 1. That gives us 9n square is equals to 3p square. 3 and 9 cancel. P square equal to 3n square. P square is a multiple of 6. Therefore p square is a multiple of 3. So p is also multiple of 3. Thus we find both p and q are multiples of 3. 3. So our assumption that p and q are co-prime integers is wrong. So our assumption p and q are co-prime integers. So our assumption is wrong, and 1 by root 3 is an irrational number.